Okay, so let's just do a quick overview of conic sections. This is just going to be really about the equations. So remember we had circles, and the general form for the equation, or I should say the standard form for the equation of a circle is x minus h squared plus y minus k squared equals r squared. And the important pieces that the equation gives us right away is we know that the center is at hk, and we know the radius is r. Now, then we did parabolas. And parabolas, we actually had 4 different forms. It just kind of depended on which way that the parabola opened. So we had x minus h squared equals 4p y minus k. And then we had x minus h squared equals negative 4p y minus k. And then we had y minus k squared equals 4p x minus h. And then we had y minus k squared equals negative 4p x minus h. And so remember, when the x is squared, and it's easy to remember because that's what you're used to, that's what you learned last year in integrated math 2, was when the x is squared, it's opening up or down. When it's positive, it's opening up. When it's negative, it is opening down. So we know this guy opens up, and this one opens down. And then when the y is squared, that's going to open left to right. If it's positive, it's to the right, and if it's negative, it's to the left. So this opens right, and this opens down. And then the important things that this equation gives us is the h and k this time is the vertex. So the vertex is at hk. And the other thing is that p. So do you remember what p stands for? P is the distance from the vertex to the focus or directrix. And the purpose of this video isn't to do a full overview, a full summary. So if you forgot what the focus and the directrix is for the parabola, you can go back and refer to those videos. Then we had the ellipse. In the ellipse, the equation was x minus h squared over a squared plus y minus k squared over b squared equals 1. And then the important parts here, we have hk, a, and b. So the center of the ellipse is at hk. And then a is the horizontal distance from the center to the ellipse. And then b is the vertical distance from the center to the ellipse. Now I am going to put this also here. Remember that we have these equations. If a is the biggest value, then a squared is b squared plus c squared. But if b is the biggest value, then b squared is a squared plus c squared. And that gives us our ellipse. And then finally we had the hyperbola. And the hyperbola, that we had 2 because it depends if it's a vertical or horizontal one. but it's very similar to the ellipse. Just has a minus sign instead of a plus sign in between the fractions. Oops. Bring out the over b squared. So there's a hyperbola, and it's either the x is positive or we could have the y positive. And then think about which one's going to be vertical and which one's going to be horizontal. And remember, if the x is positive, that means it's aligned along the x-axis, it's horizontal. And if the y squared is positive, then it's vertical. And then the key pieces here, we know the center is at HK. And now A and B are slightly different from the ellipse because it depends if it's horizontal or vertical. Because remember, we'll just have vertices along one axis, but not along the other. So if it's a horizontal ellipse, then the vertices are horizontal. So perhaps what would be better is actually to move this down. And then let's say for this guy right here, if it's a horizontal hyperbola, then A is the distance from the center to the vertices. But if it's a vertical ellipse, then we're going to look at B is the distance from the center to the vertices. But HK is always the center. And then finally for the hyperbola, it's this equation. C squared is A squared plus B squared. So this is an overview. I'm going to kind of flip back and forth a little bit to look at these. So when you're writing the standard form for a circle, notice that you get the the x minus h and the y minus k. You get those by themselves. There's no coefficient in front of them. But for an ellipse and a hyperbola, this time you have to make this side equal 1. So you may have coefficients over on this side, but it's all about making this side equal 1. And then for the parabola, it's all about isolating whatever is being squared. So that's the key when you're writing the equations. Now the last thing that I want to look at is, it's called the general form. We've actually been looking at it. I just never really formally called it that. The general form of a conic. So these were the ones that we ended up completing the square on. So the general form for a conic, all conics can always be written in this form. ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. They can always be written in that form. Now this term we didn't even look at. We didn't have a single xy term in anything we were dealing with. That gets a lot more complicated. bxy, this is what's going to rotate the conic section. So everything we looked at was vertical or horizontal. We didn't look at anything that was diagonally oriented. If b does not equal 0, that's going to diagonally rotate your conic. So that's a layer that we didn't even look at. We're not going to consider this here. So now let's just look at really quickly, how do you know, just by looking at the general form, what you have? And it's actually pretty easy. So I'm going to go back up here super quickly. If we go to the circle, if we go to look at the circle, the coefficient here always had to be 1. And so that's going to automatically force the coefficient for x squared and y squared to be the same. So going back down here, you have a circle if A equals C. If your coefficient of x squared and your coefficient of y squared are the same. Now, if for a parabola only has an x squared or a y squared. It doesn't have both. That means A or C has to equal 0. A or C is 0. And then the only difference between the ellipse and the hyperbola is that the plus and the minus sign. So A and C have to be the same sign to be an ellipse, but they can't be equal. So A is not equal to C, and A and C have the same sign. And then finally a hyperbola, just A and C have different signs. So it's really easy to know which one you've got, and then once you know which one you've got, then you know how to make your equation look. So for example, we're just going to do one little example. Okay, so let's look at this one. So identify the conic and write in standard form. Well, we don't know what the standard form is going to be until we know what kind of conic it is. And we can see that the coefficients of x and y squared, x squared and y squared, we got 2 and 1. They are not the same. It is not a circle. We have both squared terms. It can't be a parabola. But they both have the same sign. And so therefore, we know it's an ellipse. We know that capital A is 2 and capital C is 1. That is going to make it an ellipse. Remember that if A and C are not equal but they have the same sign, it's an ellipse. A and C are not equal but they have the same sign. It's an ellipse. So that's all you got to do. Now that we know it's an ellipse, remember now we know that the form is x minus h squared over a squared plus y minus k squared over b squared equals 1. So we know that we need to complete the square on both x and y, but our ultimate goal is to get this right-hand side equal to 1. So let's go ahead and do it. So I'm going to go ahead and collect my x's and my y's together and also factor out. So I got a 2x squared minus 4x. I'm going to collect these two terms together, but I also got to factor out the 2. I always have to factor out the coefficient of the squared. So it's going to be 2 times x squared minus 2x. I'm going to leave that gap right now so that I can complete the square. And then I got to collect all my y terms together, but oh, I've only got one y term. Well, that's easy. I don't have to complete the square there. And then I'm going to move that negative 4 over to the other side. Now I can complete the square. So I know that I have to put a 1 there. Half of negative 2 is 1, and negative 1 squared is positive 1. But it looks like I added a 1, but I really added a 2. 2 times 1. So I got to add a 2 over here. So I have 2 times x minus 1 squared plus y squared equals 6. So I've completed the square, but now I have to make this equal 1, so I'm going to have to divide everything by 6. Divide by 6 here, divide by 6 there. And it simplifies to x minus 1 squared over 3 plus y squared over 6 equals 1. And now I have the standard form, specifically for the ellipse. And there you go. And that is conics in a nutshell.